All right, so really quick, once again, our warm-up for today was warm-up number 21. It said add, subtract, also identify excluded values. And we had for number 1, x plus 6 over x squared minus 7x minus 18 minus 2x over x minus 9. And that's for you to practice. And then our agenda for today, we had warm-up number 21. We have a pop party. Some of you already took it. Those of you that are watching this, you probably haven't taken it till tomorrow. Then we have product and quotient of rational expressions. That's what we're covering today. And your home plate for tonight, pages 446, 447 only. Make sure you work on those. All right. And your asynchronous code for your Nearpod session is IZC46. 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 All right. Your home plate for the weekend was page 9.1, practice AB, all only. So you already turned that in Canvas. Sure you took a picture of your works and so on and so forth. And once again, your home plate for tonight, page 446, 447. Let's get started. Our objective for today, can multiply and divide rational expressions. Once again, I can multiply and divide rational expressions. Get a fair model going for rational expressions. Fill that in. Definition, example 1, non-example, and 1 hashtag. I'll give you 1 minute to get started. Ready, go. All right, so hopefully you finish that fair model by yourself. And really quick, look up, guys. You guys see my shirt? It was a gift from a student. You know how I always tease you guys that some of the work looks like Q merch or something? Well, they actually took a problem from the video, one of the videos, and they made me a shirt. Let's go. We're going to get there, by the way. You're going to have to do this, and this is only half of it. Yes, let's go. All right. So we started off with quotients. Definition of quotient says the set of all fractions where m and n are integers. Let me repeat that again. M and n are integers, and the denominator cannot be equal to 0. And why do we need to know that? Because we're still working on excluded values, which means any value of the variable that makes the denominator equal to 0. All right, I'm going to take you back in time. All right, writing utensils down, look up to the screen. I'm going to take you back to elementary, to when you were, I think, in the 2nd or 3rd grade, when they started having you multiply fractions. You're like, oh, yeah. So let's say I gave you the fraction 2/3 times 5 over, give me a number, Manny, 5 over
6.
Okay, 7. All right. So, so to multiply these, what do? Just 2 times 5 is what? 10. And 3 times 7 is what? 21. This process we're going to do today, but with polynomials. Let's go. The other process that we're going to do today is division. Here it goes. 2/3 divided by 5 over 7. And the process goes as follows. Some of you were taught keep, change, flip, something like that, right? And what did I tell you when you got to my class? I said, no, multiply the first fraction times the reciprocal of the second. Reciprocal of the second. What is the reciprocal? 7 over 5. And what does reciprocal mean? It means that any number that I multiply that number by to give me a giant 1. So 5 over 7 times 7 over 5. That is 35 over 35, which is a giant 1. So once we do this, then we know what to do. Yes, this is 14 over 15. All right, so now really quick, look up to the screen. Once again, those of you that were with me before, I already went over this, but here it goes again. When we do division, the reason we do this, not because your elementary teacher told you, it's because it's part of the definition for rationals. The definition says, look up, if I gave you this, 2/3 divided by 5 over 7. Doesn't that look kind of funky? Yeah, because according to the definition, we can't have fractions in the denominator. what can we have? Integers, which means the smallest integer I can think of is a giant 1. Therefore, what can I multiply this fraction to give me a giant 1? Well, the reciprocal, 7 over 5. What is 7? 7 times 5, that's 35. 7 times 5 is 35, and that's a giant 1. But whatever I do to the numerator, I do to the denominator, I do to the numerator. And then from there, I multiply these, I get 14 over 15, and all that over 1. And if it's over 1, that means it just gives us 14 over 15. This is the why we do the reciprocal. Why? Because of the definition. So now that I showed you where it comes from, let's actually apply it to now polynomials. Let's go. Copy this problem, please. Example, oh, my bad. I'm going to give you steps once again, just to make sure that we have our process down. Steps. Number 1, factor completely. I'm going to do that in black. Step 2, multiply the numerators and denominators. I'm going to do that in red. And step 3, simplify, which is divide out the common factors or the giant ones. I'm going to do that in green. Copy that. I'll give you 1 minute, 1 minuto. All right. I'm going to leave those on the top right of the screen. So if you haven't finished, they're on the top right. But it says example 1, copy this. It says compute the product or quotient, then simplify to lowest terms. And at the end, also identify any excluded values. Make sure you write the instructions, please, at least for this one. The rest of the examples that I give you, you don't have to write the instructions as long as you copy for this one. Example number 1 reads 3x squared over x squared minus 2x minus 8 times 2x squared minus 6x minus 20 over x squared minus 3x minus 10. Copy that. 30 seconds. All right, here we go. So I'm going to start with black and writing utensils down really quick. Let me just go over the step. You'll copy it and you'll know the routine. Okay, here we go. Look up to the screen. Step 1 says factor completely. Does it specify as to what? No. When we did addition and subtraction, it specified that only the denominators. But this time, since it doesn't, we're going to factor the numerator and the denominator. So here we go. How can I rewrite 3x squared in factored form? 3 times x times x. Okay. How can I rewrite x squared minus 2x minus 8 in factored form? Well, let's see. Negative 8 on top and negative 2 on the bottom. What 2 factors of negative 8 add up to negative 2? It gives us 2 times negative 4. 2 times negative 4 is negative 8. 2 and negative 4, that's negative 2. So my factors are on the denominator, x plus 2, x minus 4. All right, I'm done with this fraction. Now let me factor this one. What is the first thing we're going to check here to factor this numerator? GCF. First of all, it is in standard form, so GCF is what? 2. We have x squared minus 3x minus 10. Can I factor this a little bit more? Let me check. Negative 10, negative 3. Factors of negative 10 that add up to negative 3, 2 and negative 5. So my factors for this are x plus 2, x minus 5, plus the 2. So I'm going to write my numerator, 2, x plus 2, x minus 5. And also notice this denominator, you need to factor this. You're like, Mr. Q, but isn't it exactly like this one? Yeah, so then we already have the 2 factors, which are x plus 2, x minus 5. Copy that, please. All right, so you already copied that. That was step 1, which meant factor completely. We factored the numerator for this one and the denominator. There it is. Times. We factored the numerator. First we did GCF and then the power rater. We got that. And this, we saw that it looked like that. So we just got those 2 factors that we had already done. Okay. So I'm done with step 1. Step 2, I'm going to switch to red. Step 2 says multiply the numerators and denominators. Remember how I showed you earlier how to multiply the fractions? So I'm going to multiply the numerators going that way. So check this out. I'm going to start, and I'm going to leave them as factors for right now. So I'm going to start with the smallest factor, which is what? 2. So I'm going to write 2 times what? 3 times x times x. Does everybody see that? 2 times 3 times x times x. Okay, and what are my other two factors? X plus 2 and x minus 5. Okay, that's the numerator. Let me do the denominator. All I'm going to do is rewrite all of these because they're multiplying. Is that correct? Yeah, so I'm going to write x plus 2, x minus 4, x plus 2, and x minus 5. All right, copy that, please. All right, you already copied that. That was step 2. It just said multiply the numerator and the denominator. We did that. Okay, I leave it in factored form because look at step 3. Step 3, I'm going to switch to green. It says simplify by dividing out factors or identifying what? Our giant ones. You guys see the first giant one? Yeah, right here, x minus 5. There's the first one. You see another one? Yeah, x plus 2. There it is. Are there any other giant ones? No. So what's left on the numerator? 2 times 3 times x times x. So at this point, I can multiply them out just so that I can leave it in simplified form. 2 times 3 is 6. X times x is x squared. And I'm going to leave these as factors, x plus 2 and x minus 4. Some of you are saying, Mr. Q, or you're questioning your noodle. Why did we multiply the top ones and not the bottom ones? Because the bottom ones, remember that usually we use those to show the excluded values, but let me show you right now when we get to that part. All right, copy that. All right, so here goes the process. Factor completely the numerator and denominator, yes. Multiply the numerators and denominators, there it is. Identify giant ones, yes. And here's our simplified product. This is our product, my bad. Product, because we just multiplied product. Okay. However, they want us to do at the end what? Identify any excluded values. So check this out. Excluded values. Look up before you do work or extra work. Look up. Look where I'm going to get my denominators for excluded value. Not from here, but I'm going to get them from here. X plus 2 equal to 0, x minus 4 equal to 0, and x plus 2 equal to 0, x minus 5 equal to 0. Copy that. Make sure you make a note that we're not going to use the denominators from the product. We're going to use the denominators of the two original fractions. Okay? That's how we get our excluded value. So I solve minus 2, x equals negative 2, plus 4, x equals 4, minus 2. Oh, we already did this one. I don't need to do it again. And plus 5, x equals 5. So my excluded values are negative 2, 4, and 5. Once again, make sure you make a note right here somewhere. Put a little asterisk, a heart. Don't use these for EV. Make a note for yourself, please. Got it? All right, show me where your fingers, how comfortable you are with these so far. We got some 4 5s, 4 5s, 4 5s, 3s, 4 5s. Okay, 3.5. Okay. So we're going to do one together. And notice it's going pretty fast. And I don't know if you guys notice, it's not as intense as addition and subtraction because we don't have to add anything. We just need to factor, multiply, and simplify. That's what makes it a lot simpler than the other. Okay. All right, example 1Q. Ready? Here we go. Example 1Q reads x squared minus 8x over 14 times x squared plus 8x plus 15. And then that fraction times 7x plus 35 over x plus 8. All right, I'll give you a head start for you to do the first step and then wait for me just to make sure that you got the correct factoring completely for each fraction, and then we'll move on. I'll give you some time, 20 seconds, go. All right, let's see what we got. So step one reads, once again, I'm going to do that in black, factor completely. Look at the numerator. Is it in standard form? Yes. It's a binomial. Okay. But can we factor out a GCF? Yes. The GCF for this one is x, and we're left with x minus 8. Hands, have you got that? Okay, good. The denominator. What are the factors of 14? Oh, that's 2 times 7, Mr. Q. All right. How about x squared plus 8x plus 15? Let me do that over here. 15 and 8. What factors of 15 add up to 8? 3 and 5. So I'm going to write x plus 3, x plus 5. Okay, there it is. Multiplication. Let me go to the second one. Is it in a standard form? Yes. Can I identify GCF here? Yes. The GCF is 7, and I'm left with x plus 5. Is there a GCF on this one other than 1? No. So I just bring it down, x plus 8. Hands, if you got that? All right. So step 1 is done. You're like, Mr. Q, this is tweezy. I know. Step 2, multiply numerators and denominators. So I'm going to go this way. Here we go. Start with the number 7 times, there's no other number, so I'm just going to write 7 times x, which is this one. And then I'm going to write the binomials, x minus 8 and x plus 5 over, let's see. Is there another number over here by itself? No. And by the way, notice this one's a binomial. Make sure you put it in parentheses like so you won't make mistakes with these numbers. So these, I'm just going to leave them as is, 2 times 7. And then my binomials are x plus 3 times x plus 5 times x plus 8. All right, we're done with step 2. Step 3, simplify by dividing out giant ones. So does everybody see the giant ones? Yeah, the x plus 5, it's obvious. But the other one that's obvious is 7 and 7. You guys see that? 7 and 7. Okay. So what does that leave us with on the numerator? We have x times x minus 8. And the denominator, what do we have? The 2, the x plus 3, and the x plus 8. 2 times x plus 3, x plus 8. And we are done. This is our product. Hands, if you got that. Yeah? Yeah, it's simple to follow. As long as you just follow the process, you'll be fine. Show me how comfortable you are up to right there. All right. Find me the excluded value. See if you can do that by yourself. See if you remember the little note I asked you to write. I'm going to switch to blue. Excluded values. All right, let's see. So Chico, tell me what to write.
X plus 5 equal to 0.
Okay, x plus 5 equal to 0.
X plus 3 equals to 0.
X plus 3 equal to 0.
X plus 8 equals to 0.
X plus 8 equal to 0. And just for the sake of it, we're just going to write 2 equal to 0, 7 equal to 0, even though these are what? Not true. Is that correct? Yes, Mr. Q, they're not true. All right. So yeah, we're not going to use those, but we are going to solve for the other ones. Minus 3, x equals negative 3. Minus 5, x equals negative 5. And minus 8, x equals negative 8. So my excluded values are negative 3, negative 5, and negative 8. All right, show me with your fingers how comfortable you are with that so far. 5 4s, 5 4s, yeah. Yeah, we got this, yeah? You're like, Mr. Q, this is simpler than adding and subtracting. You should have given us a parte on this. Okay, no problem. But not right now. So you looked at me like, all right. So we got this down. Now check this out. I was going to give you another one, but you can do your practice with the home play. Look up to the screen. Now, we're going to get into division, but before you copy the steps on the screen, look up. Step 1 says to divide, multiply the first fraction times the reciprocal of the second. I explained that earlier. Is that correct? Yes. But look at the rest of the steps. Step 2 is what? Factor completely. Step 3, multiply the numerator and denominator. Step 4, giant ones. So what is the only step that you should copy for division? Yeah, step 1, because the rest is the same. So copy step 1, please, in blue. Step 1 for dividing, we have to multiply the first fraction times the reciprocal of the second. Multiply the first fraction times the reciprocal of the second. For division, we need to multiply the first fraction times the reciprocal of the second. I'm going to be doing that step in blue to start. I know that we use blue for excluded values, but I'm saying so that we can start the process of division. Okay? Once again, step 1 is what? Multiply the first fraction times the reciprocal of the second. All right, copy this example down. Example 2. The instructions are still the same, what we copied at the beginning. That's why you don't need to copy it. But here's the example 2. It reads, parentheses, x plus 7, close parentheses, squared, over x squared. From there, divided by, second fraction reads x squared plus 9x plus 14 over x squared plus x minus 2. Copy that. 20 seconds. All right. Here we go. Let's do first step together. It says multiply the first fraction times the reciprocal of the second. So that means the first fraction stays the same. So I'm going to bring it down. X plus 7 squared over x squared. We're going to multiply that times the reciprocal of the second. What do we need to do for the reciprocal? Some of you say, just flip it, Mr. Q. All right. So then we write x squared plus x minus 2 over x squared plus 9x plus 14. Does that look familiar now at this point? Does this look familiar? Yeah, right? We've been multiplying. So what's the only thing key to remember for division? The first thing is that we need to multiply the first fraction times the reciprocal of the second. All right, let's do the rest together. Here we go. Step 2, factor completely numerator and denominator. So how can I write this? Alvaro, the first fraction. Tell me what to write.
X times 7 and x times 7.
Yeah, x plus 7 times x plus 7, and the denominator is x times x. Times. Let's see, Viv, help me with the numerator for the second fraction. -2 and 1. Factors of -2 that add up to 1.
1 and -2.
1 and -2, close.
Oh, -1 and 2.
Yes, -1 and 2. There it is. All right, so therefore we get x minus 1 and x plus 2. That's the numerator. Let's go to the denominator. Oh my goodness, did I go forward? Hold on. Sorry. Oh my goodness. All right, there it was. Let me write this again. X plus 7 times x plus 7, x times x, times the reciprocal was x squared plus x minus 2, x squared plus 9x plus 14. All right, let me just write the step. I don't want people to get confused on the video. So this is x plus 7 squared over x squared. All right, so then now in step 2, we do x plus 7 times x plus 7 over x times x times, and Viv said x minus 1 and x plus 2 About for this one, guys, we had 14 and 9. So that is what, 2 times 7? Yeah? Yes, Mr. Q. All right. So my factors are x plus 2, x plus 7. All right, step 2 is done. Let's go to step 3. Multiply the numerator and denominator. So basically, I just rewrite them. We got x plus 7, x plus 7, x minus 1, and x plus 2. The denominator, we have x times x, x plus 2, x plus 7. So we're done with step 2. Let's go, step 3, let's go to the last step, which is simplify giant ones. First one is right here, x plus 7, x plus 7, and the other one's right here, x plus 2, x plus 2. What do we have on the numerator? The numerator, we have x plus 7 and x minus 1. Denominator, we're left with x times x, or x squared. I'll leave it at that for right now. All right. Show me with friends how come you are so far up to right there. Okay. And the last thing. So pay attention to this part. Write your utensils down. Excluded values. Look up. You're like, we know, Mr. Q, this one. X equals 0. X equals 0. Yes. These. X plus 2 equals 0. X plus 7 equals 0. Yes. However, check this out. This is division. Pay attention. The original division fraction was here. That means this is also a denominator. What are the factors of this one? Oh, they're right here, Mr. Q. So that means I need to use those also for my excluded value. X minus 1 equals 0. X plus 2 equals 0. Copy that, please. Make sure you make a note of it. We do need the last two right here, but we also need the one from the division, the original denominator. So this is done. This is done. Minus 2, x equals negative 2, minus 7, x equals negative 7, plus 1, x equals 1. And let's see, this one we already have here, so I don't need to solve it again. So my excluded values are 0, negative 2, negative 7, and 1, because 0, we have them twice, so we only use it once. 0, negative 2, negative 7, and 1. Woo, let's go. And pretty much that's the home plate, guys. Multiplication and division of rationals. All right, show me with fingers how come you are with division now. 1 being the lowest, 5 being the highest. Yeah, some 5, 5, 5, yeah. Any questions before we leave? Autograph?
Mr. Q.
Yeah.
Mr. Q, why don't we write x squared as the denominator?
We can leave it at
Why do we write x times x instead of x squared?
yeah, you can write x squared if you want. Everybody see that, guys? So here at the end, you can leave it as x plus 7, x minus 1 over x squared. And that's simplified. Yeah, that's fine. It's just my brain that works like that. So. All right. Have a good one, guys. Enjoy your home play. Once again, tutoring today in the afternoon. See you guys. Be there or be elsewhere.